Hey, I'm gonna be sitting over there. Don't put the pillows there.
You break down the whole thing, yeah. Everybody have a good weekend? Anybody do anything fun? Yeah, what'd you do? Oh my, okay. I'm gonna have to, she,
From here, all the way here.
Not fabulous.
I think that research.
Don't speak.
Don't give away the secret.
You're giving it away.
Giving no secret. What's being admitted? Oh, he admitted he used ChatGPT for the stuff. I'm like, it's giving away the system. Those are government secrets. The Illuminati will come to. I got my.
Everybody's here. Do you want a chair, baby? You sure? Okay.
I reclaimed my
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
I reclaimed my phone.
All right, everybody's here because Liam's not gonna make it today, so we can actually start a smidge early. Real quick, I did put the blinds down because we're gonna be watching the video today, but if you hear a strange thumping over here, my bluebird has decided, one of my male bluebirds has decided to act like the Oriole from last year and has been continuously banging into that window for 3 days because he sees a male bluebird in the window. And it's yeah, Cole and Micro are working on a car, so that's gonna be loud. But anyway, the internet said to take a dry soap bar and to like make a grid on the window. So like I've gone and I've done this because hopefully it'll make it. Like I've really done this, but if you hear banging, it's just him. He's just really aggressive. He does not want that other dude hanging around his nest because he's claimed the box for his own. So anyway, yeah. Did y'all see I shared the video of my goofy Oriole in last week's email, that goofy Mr. Stumbles guy who just banged into my windows for weeks. All right, so we're gonna go ahead and do today's lesson. As soon as it's done, we're gonna start the documentaries. I hope you guys had a chance to look up the information you could look up beforehand. And if not, you're definitely gonna wanna do that in between now and next week, because next week you're gonna kind of like wrap it up and hand it in, right? So there are a lot of questions that require background research, so you're gonna want to go and look those up. All right, so you have a test this week too, which means that you don't have homework, so that gives you little time as well to work on the lab. This was your last unit test. Your next test is your final. Because your next unit gets wrapped in with your final, so we're already there. A little scary, right? All right, so again, don't forget the dance. Come to the dance, please, it's so fun. And I need people because I've rented the place. So I have to have tickets to pay for the rental because I'm not dancing. So come if you can, it's a lot of fun. I will feed you, I promise. Okay, don't forget there's a sign-up sheet for your final project. You need to get that done. If you haven't already done it, you need to go on there, put in your topic now, make sure nobody else has put it in. I'm gonna, I'll put a deadline for this sign up in your weekly email. So
Who put the Sesame Street?
That's awesome.
That is her. How's that?
I like that.
Jack, I did put in blue though.
So those of you who completed your homework,
my childhood hero here. You guys got, a lot of you guys got to meet Don Herbert. I suggest highly, when you have nothing else to do and you're staring at YouTube, looking at useless videos, look up his stuff. It's really, really fun. He's really great to watch. And the only thing is, like, by today's standards, it may seem a little creepy because he was just like this old man who lived by himself and invited neighborhood kids over to his house to do science. Kind of strange, like he's friends with all neighborhood kids and he knows them all. And he's like, "How are you, Bobby?" And he's like, "I'm great, Mr. Wizard. How are you?" And then they do something weird together. But
Like that.
yeah, I mean, it wouldn't be on today. Like they would have to find a different premise today, but it was still really cool. I really wished he would be my neighbor when I was a kid. Yeah. Yeah, okay. There was one in particular I remember where they had like a glass of grape juice on the ground and they had some kids standing multiple stories up on a balcony and he was trying to use a straw to drink the grape juice. And they were different size straws, like there were more narrow ones and there were, you know, ones with larger diameter. That one was fun. And one where he put like cellophane tape, like Scotch tape, all crisscrossed and shine a light through it. And it was all prismatic. And there's one where he cooks a hot dog with a battery, all kind of fun stuff like this. So you guys got to see him cook outside, which was fun too. All right, so we're going to start by talking about populations and our use of natural resources, because here we are about how we impact the environment. That's where we are today. So all organisms use resources to maintain their existence, and the use of these resources has an impact on the environment, obviously. What are the 3 things that all living organisms do? Bailey. Breathe, kind of, we're getting there. All right, somebody give me one. Drew. That's one, reproduce. Okay, let's see, Caitlin. Getting there. Okay.
They die.
They die. Okay, they die. Anybody else have another one? Yes. They live. Okay, we're getting all kinds of interesting answers here. They drink water. So here's the thing. Here's what all living organisms do. Obviously, they live, means they're alive. And the way we define that is they grow and reproduce. That's what makes something alive, something that can grow and reproduce. All right. So currently, the Earth is experiencing a population explosion. Now, this is particularly important to keep in mind, this stuff here about population growth, because it's going to come up a lot in the 2 climate hustle movies that counter the inconvenient sequel we're watching today. So keep this stuff in mind. So the demand for resources is going to increase along with, yeah, Milo? That's right. Okay, so as population grows, increases, the demand is going to increase. What kind of relationship is that, Alex?
Not inverse, the other one.
Not inverse. What's the other one?
Standard?
Bailey? No, she was going to say that, James? They're directly proportional. Okay, so these things are directly proportional. Inversely proportional would mean one goes up, the other goes down, right? They both go up together, both go down together. That is directly proportional. And that applies to everything. So I'm going to move this little sucker out of the way. So this is the size of the world's population over the last, this should be a comma, 12,000 years. All right, so we'll have a look here. This is what we're estimating here. And we're bumping along. And right around in here, which is year 0, we start to see some decent growth. And then, whoa, holy moly, what's going on here? So we get huge growth here, all right? So keep this slope in mind as we start talking about population size and how it impacts resources. And this was from, based on estimates by History Database, Global Environmental, and UN data. So that's where this particular chart came from. So basically from year 0, when we had like what, 190 million, we now have almost 8 billion. That's a big jump in 2,000 years, especially considering this is only 12,000 years worth of data. So this is another one that is, go back. This is another one that is UN data and a couple of others. This is world population from 1800 to 2022. So this is our more recent slope. So that giant slope that you just saw here, this big old slope, where did it go? Can I go backwards? Hello. Oh, this slope, this hugely sharp thing right here is this when you bring it down and spread the graph out a bit more. Okay, so now you can see it in a little more granular fashion. And so It says 1800 to 2022 and median variant projection with 80 and 95% prediction intervals. So basically what they're saying is they're thinking they're going to be pretty accurate in their guesses going forward. And it's going to do one of these things. There's a median projection here. What's the median base versus like the average? Somebody tell me, Alex.
I believe, mean is average, median is the
Mhm.
you knock out the lowest and highest
Yeah,
in a pair,
Mhm.
and it's whichever one's in the center of the data set.
that's correct. So if you had,
You average them.
right, so, okay, it's kind of like, you can think of it like this. An average is if we took the ages of everybody in a family, okay, and we found the average age, we would have added them all together and divided it by the number of people in the family, right? But the median, sorry, is what's kind of in the middle. So if you had like a really old grandma with the family or a baby with the family, it's going to skew your average one way or another. The median is kind of where the center would be without that giant skew on either side. So these are projection intervals, what they think is going to happen if population increases by 80% or decreases by 80%, or it goes up by 95 or down by 95% from its current growth. So keeping all that in mind now, this is all the people in the world. So it says each country's size represents the size of the population in 2018. So each little square, little pixel there, represents 500,000 people. In all 15,299 squares shown here, where the world's 7.633 billion people live. So what they've done is they've taken one little chunk, and that represents 500,000 people. And then they've taken all the world's countries and they have turned them into little chunks. So you can see, where are most of the world's people? What country? China, followed by India. Yep. A lot of people in China.
Basically, India overtook China.
It may have in the last year or two. This is, like I said, this data was what, 2018, 20. Ooh, what this data is.
I think
It's too small. I can't see. Oh, 2018. This is 2018. A lot of this is 2018 data because we lost some data collection over the last couple of years for obvious reasons. Like people didn't leave their houses and didn't do anything. So this is keep in mind kind of where everybody is. All right. So some of these countries have nothing. Yeah. India's basically taken over all of Africa there. You're right. That's a little crazy.
Considered a subcontinent.
Pretty much. All right. So go away. Come on. There we go. Oh, I hate that. Whenever I zoom in and it gets weird on me. Oh, come on, stop it. Oh my goodness. Okay, now we're here. All right, limits to population growth. So as the number of reproducing adults increases, the rate of population growth increases. Okay, so again, that's directly proportional, and that seems pretty obvious, right? Assuming that most adults in a population are going to reproduce. Now remember, this doesn't just apply to humans, but in our case, it does here. So the population then experiences what? Which is a pattern of growth in which the population grows faster as it increases. Use it. Exponential growth. Okay. What's an exponent? James? It's a number. Thanks so much. Who else can describe it? Jack, can you do it?
I should.
Think about it, like in math.
Yeah, it's the number to the side
Mm-hmm.
of the big number.
Right. So if it said like,
the numbers, it's
3,
how much the
and then like a superscriptive 2,
Yeah.
what would that mean about the 3?
You multiply 3 times
3 times 3, right? So it's like a double or a triple or a quadruple or whatever, but it's not times 1 times 2 times 3. It's that number times itself that many times. So that's what we mean by exponential growth, is if you had 10 reproducing adults and they all reproduce at a rate of 10 offspring, now you've got how many offspring?
50.
No, if you have 10 adults and they each produce, oh yeah, well, okay, let's say 20 then. 10, let's say 10 female that produced 10 and they were 50-50, you would be correct. So if you had 10 reproducing adults and they were male and female equal, and then you had their offspring was always equal, then you would have 50, right? And then if you had that 50 and they're going to reproduce with that same 50, it's just going to keep doubling. You're correct though, very smart.
Yeah.
So population then experiences exponential growth, which is a pattern of growth in which the population grows faster as it increases in size. Oh, didn't mean to click that. So despite this, there are factors that limit growth, such as the availability. I have a hard time with that one. With food, water, clean air. Obviously, if there's less food, your population's not going to grow as quickly. And if we think back to biology sciences, it's those that are going to be most adaptable that are going to reproduce. And that's when you see evolution, is when you put strains on resources. Very often that's what does it. Strains on resources or changes in habitat. So these factors cause the population to level off. Now, level off is when it gets to a point where it's not really growing hugely and it's not really shrinking hugely. It's kind of oscillate around that area. Okay. So the number, this is carrying capacity, right? The number that any given environment can hold is its Milo. That's carrying capacity. Okay. And this is true for everything, different organisms, people, whatever, it's carrying capacity. So when a population has not reached its carrying capacity, there are more what than what, Bailey? There are more births than deaths. I don't know why I'm accidentally hitting things with my elbow. That's right. Okay. So there are more births than deaths, and a population that's at its carrying capacity for its environment is said to be at equilibrium. So equilibrium is when it has leveled off. It's just going to bounce around there. So it's going to continue to fluctuate around its carrying capacity as long as there are enough resources available. Strange things happen to the climate or whatever, then you'll see changes, but that's usually because it's impacting the resources. So this is interesting. Now, we've been talking this whole time about population getting too big and the concerns with resources, and that's going to come up again in the videos, like I said. So see what this guy says right here. And I'm going to take 1 second while this is on. I'm going to run down to the basement and back up because I'm fighting with my copier. Because I'm trying to get you guys your.
Before. In 1982, American professor bet $1,000 question with stakes that couldn't be higher.
Okay.
Would the Earth run
Right
out of
back.
resources to sustain a growing human population? One of the Stanford biologists, Paul Ehrlich, who wrote the best-selling 1968 book, The Population Bomb. The global population had grown rapidly since World War II, and Ehrlich predicted that millions would starve to death as the population increased faster than the food supply. He drew from the ideas of 18th century economist Thomas Malthus and related work from the 20th century. Malthus had posited that population growth, if unchecked over time, would always outpace food supply. Through the 1970s, it seemed like Ehrlich was right. Famines, pollution, and political unrest had many concerned that humanity was on the brink of such a crisis. And some governments considered and even implemented policies to limit population growth. Betting against Ehrlich was Julian Simon, a professor of business and economics. He analyzed historic data from around the world and found no correlation between a growing population and a decrease in standards of living. In fact, he found the opposite. He argued that Ehrlich's work and that of Malthus before him was based on theoretical calculations, while the real-world data told a different story. But then he departed from the data himself, claiming human ingenuity would always find alternatives to compensate for diminishing resources. If that seems overly optimistic to you, well, you're not alone. Ehrlich and other experts found Simon's claims preposterous. In June 1980, Simon wrote a scathing article for Science magazine that incited a heated debate of published articles between the two men. Simon said he should have placed a wager against Ehrlich years before, when Ehrlich ventured that, quote, England would not exist in the year 2000, unquote. Later that year, Simon called Ehrlich a false prophet and challenged him to a bet. Their feud also touched on the debate about whether to prioritize environmental protections or economic growth, a key issue in the American presidential race between Jimmy Carter and Ronald Reagan. After some debate, they set the final terms: $200 on the price of each of 5 metals. If the price of the metal decreased or held steady over the next decade, Simon won. If the price increased, Ehrlich won. Wait, what? Weren't we talking about overpopulation and famine? What could the price of metals possibly have to do with that? Well, the reality is that the price of metals may not have been the best choice. Many factors impact these prices that have nothing to do with overpopulation. But their reasoning was as follows. Metals are finite natural resources used in all sorts of manufacturing. Ehrlich believed a growing population would consume such finite resources, and scarcity would drive the price up. Simon thought humanity would find substitutes for the metals and the prices would stay stable or even decrease. So, what happened? The world population would continue to increase over the next 10 years, but the price of all 5 metals decreased, making Simon the clear winner of a bet that may not have been a great proxy for the question they were debating anyway. As for the question itself, today their focus on overpopulation represents a snapshot of history. Our understanding of what causes starvation and famine has progressed. We have the resources to support a growing human population, but we're currently failing to distribute those resources equitably, and changing that should be our priority. And we no longer see population size as a primary cause of environmental degradation and climate change, or limiting population growth as a viable solution to these problems. Rather, experts largely agree that our focus should be on replacing unsustainable technologies and practices with sustainable ones, and that economic growth and environmental protections don't have to be at odds. In October 1990, Julian Simon received a check from Paul Ehrlich. There was no note. So how can we feed every person on the planet a healthy diet?
So we can all
And how can
bet
we do
on
so
stuff, huh?
without further damaging
We
them?
could, I suppose.
Find
He
out.
was salty. He's
I don't
like,
know that.
Here's my heart.
So we've heard all these concerns, right? We've got, oh no, human population's growing. We're gonna overpopulate the planet. We're gonna pollute it to death. We're gonna suck up all the resources. Okay, because population's growing, right? Wait a second. All right, so let's have a look here. This is fairly recent. This is BBC 2020. Fertility rate, jaw-dropping global crash in children being born. Now, this is July 2020. So is this impacted or not impacted by the pandemic?
Not yet,
Not yet, correct, Bailey, why is that?
because concerns didn't start till like late 2020.
It was like March 2020, but March to July is 7, right? March is 3, it's 4 months. So,
And that most of that I just be like, okay,
Yeah.
little break.
yeah, 4 months, 4 months is not enough for people to go, oh my gosh, it's a pandemic, let's not have babies. Unless we're all having premature babies, we shouldn't have seen this until, a year later. So March 2021, you might have seen a slight drop, but actually we didn't see a drop, did we? What did we see with babies during the pandemic? Yeah, people were stuck inside for hours. So that's what happened. So yeah, we had that. So we have got this jaw-dropping global crash in children being born. Now, this is a concern economically for a lot of countries. If you look here, this is the global fertility rate. So that is basically your live births per woman. So 1950, here they are, and then drop in here. There's a big drop right there. Does anybody know what that might be? Late 1960s, early into the 80s. What do you think? It's a little late for that.
Might I interest you in a war?
Oh, that's
War could be part of it. That could be part of it. No, that's a good one. Do you have a different one, Yusuf? You were gonna say war too? Yeah. AIDS, that's a little bit later, but yes, that was, and at the time, people thought AIDS was, well, at that point, though, that's a good point, because AIDS hit in like the 70s, 80s range, but initially people only thought that AIDS stayed within the homosexual community. They didn't think that straight people could get AIDS, and they were very wrong and found that out. Lily, what do you think? Sickness? Could be sickness. How about access to birth control? That's where it is, right there. You can see it, there's an actual drop. And then there's a kind of that's a decent drop. And then there's sort of a steady decline. Well, what's this about? This has to do with a lot of different things.
like favorite soda or something.
Yeah.
Like,
Mhm.
have it and then it'll level out.
Yeah, that's a lot of it. And then it's just sort of like around in here, people found, at least in the developed world, that's what this is. In the undeveloped world, or third world, whatever we want to call it, underdeveloped countries, they're not seeing this, but average out for globally, that's what you see. So again, that's what this drop was. And then you can kind of see this sort of level off through here. And so we're having less and less. And if you think about it, like, does anybody know, okay, so you probably know this, your parents on either side. Anybody know how many siblings your parents have on either side? I'm sure you do. How many?
2 on each.
2 on each, yeah,
4 for my mom and 1 for my dad.
4 and, oh, 1, okay. All right, how about you? Okay, there you go. And in your, James. Yeah, mine are 6 and 4. So if we think about it for a minute now, how many children are in your family? Average it out. Is it less or more than your parents?
Exactly the same.
Exactly the same? Could be less, more, the same. Yeah, it tends to be smaller families. A lot of this right here has to do with moving into a less agrarian culture and into a more suburban. You don't need 1 million children to work on your farm. That's some of that.
Yeah, my big grandma.
Yep. Yep. My great grandfather was one of 13. So I mean, it's not strange. All right. So how populations of selected countries might change. So this was a projection, and it turned out to be pretty accurate. China and India were growing most rapidly. Does anybody know what China did about its population issues? Because they were very concerned. What did they do?
They started reducing it if they got like more people.
Kind of. So what they did in China is they instituted it for many years. They just recently pulled it back. A one-child policy, 1 child per family, period. You couldn't have that second child. There were all sorts of systems put in place to make sure you didn't have that second child. You didn't have them. And if you did, we had a large wave in adoptions out of China. And if you want to read about some very dark history of things that have been done as far as like humanity is concerned, it's a very interesting time. And in Chinese culture in particular, male children are very valued because when you get old, it's your male child and his wife that move in and take care of you. So if you have a girl and that's your only child and she's gone to take care of her husband's family, nobody's taking care of you. And that actually resulted in a large drop in female births in China. So keep that in mind. It's a very interesting piece of cultural history. But China did that, instituted that 1-child policy because they were populating at a rate that the country couldn't sustain as far as with the governmental system they had. I'm not saying it couldn't have been sustained with other methods because it probably could have, but China's China. And that particular 1-child policy did not apply to everybody. It didn't apply in very rural areas where you had farms and you needed children to work on them. Yes.
But they took it off recently.
They did.
Because they had a drop in sales.
They did. And why? Because they had more males than females. Yep. They had more males than females in their population. That was a huge problem. Yep.
Restricting the amount of children that can be born will lead to a drop in the amount of children.
Especially when your culture wants one gender over the other. Yep.
Experts started sounding the alarm about overpopulation. They were worried because humankind was growing exponentially. We went from 1 billion people in 1800 to 2 billion people in 1900 to over 5 billion people in the 1980s. If this trend continued, human civilization would run into big problems. We would run out of, well, pretty much everything in just a few decades. But the doomsday scenario predicted by those experts hadn't happened, and it isn't going to. Here's why. Hi, I'm David, and this is Minute Earth. The big thing that's defused our population bomb is that people just aren't having as many babies as they used to. And that's happening for 2 main reasons. First, the world's poorest people are getting less poor. Just a half century ago, half of the families on Earth made less than the equivalent of $2 US a day. Today, only 10% make that little. And it turns out that families that make more than $2 a day benefit less from having lots of kids and have more control over how many kids they do have. As a result, families living above that $2 a day threshold have on average 2 kids, compared to the 5 that poorer families have. That reduction in poverty alone means that the average family has 1.3 fewer kids than they used to. Second, women are getting more educated. Over the last few decades, girls on average have gone from attending just 7 years of school to more than 11. And it turns out that girls who stay school longer tend to get married later, which means that they start their families later, which generally means that they have fewer kids. Some studies have shown that for every 4 additional years a girl stays in school, she'll give birth to 1 less child than she would have otherwise. Now, if you actually do all that math I just told you, you'll find that the numbers don't quite add up. The number of babies people are having isn't quite as low as a straight up combination of these 2 trends would suggest. That's probably because these trends overlap. Some of the women who are getting out of poverty are also getting better educated, so separating out the effects of each is really messy. We're not yet at the tipping point where the number of people on Earth is actually decreasing, but in places where very few people live in extreme poverty and lots of women are well educated, we're already seeing populations start to shrink. If these two trends continue for a few more decades, the planet's population should follow suit. So some experts are now sounding the alarm about underpopulation. They're worried that having fewer people working and spending money on stuff could blow up the global economy, which could make as much of a mess as an overpopulation crisis. Other experts, though, think it's okay if the global economy shrinks, as long as the global population is faster. After all, that would mean that, on average, everyone would have more money. We will let the experts duke it out over what might happen in the future. Either way, though, we're not heading towards a population explosion, which I think we can all agree is the bomb.
But what if I wanted to see an explosion? I don't know.
There's a sad way.
So the point about women in education also is going to line up with that same dip we saw. And again, that goes to access to family planning. That's all a big part of it. It all kind of goes together. The whole, like, the first big, not the first suffragette movement, but the second large feminist movement. That's where you see the drop, because everything kind of fell into place at one time. Yeah.
Two of the stick figures that were used on the women's education one appear to be from the latest Pokemon game, except
Oh.
they've got them reversed.
Oh.
They've got
I wouldn't know.
the smarter one.
So which one is it now? We got people complaining, we have too many, we have people complaining that we got too many babies. Then we got people saying, we don't have enough babies. So which the heck is it? So hold up, I'm trying to make this thing get out of your way. All right, so here we are. How much living space does our current population need? So we're talking about living space here, not land resources. So we're gonna do an interesting little thing. You guys are gonna take some guesses for me. So some combined data from various 2023 national census reports. So I went and looked all this up here. So blank has the global largest average house size. Who do you think has the biggest house size in the world? What country? Somebody who hasn't gone. Parker, you go once. You did go once. Chloe, you haven't gone. What country do you think is going to have the largest house size?
Ones with not super dense populations, I don't.
Just guess. Any country.
I have an idea.
Hang on, just thinking. No guess? You don't have a guess? How about you, Lily?
Is a horrible guess.
India? Okay.
So do you mean on average?
I mean average, the global average, the house size. What's the largest?
Maybe either the US.
Mhm.
or maybe Dubai.
Okay, I'll take two more. Let me take Jack.
Gonna say Dubai.
Oh, wow. What do you think, Yusuf? Go for it. You can, Australia or New Zealand. Okay.
I was guessing Canada.
And Canada. Okay. Anybody want to guess how big? Does anybody know the square footage of your house, or can you estimate square footage? Okay. So, all right. This part of this house, okay, this level of this house is probably close to 2,200 square feet. This level, the one you're familiar with, if that helps you. Okay, so here's what we have here. Our first one is going to be the US, all right? And US and Canada have gone back and forth on this one, just so you know, all right? And our average square footage is 2,400 feet for the whole house. The median amount of space per person in the US is 700 square feet. So this is if you take your average family size and your average house size, and you find out the square footage per human, okay? So this doesn't mean that, you know, one person living alone necessarily lives in 700 square feet, but there are 5 people in this house, right? And this house is a little under 6,000 square feet. So gives you some ideas. All right, so what country do we think is gonna have the smallest house size? Jack?
China.
China? Yusuf? India? Drew? India, you're gonna say India? Caitlin? England? One more. I don't know. Indonesia. Okay. All right. So Vatican City. All right. So it's going to be Hong Kong. Interesting. Very interesting. Hong Kong is very urban. So think about when you walk into IKEA.
It's a city.
Yeah, anybody ever been into IKEA and looked at the like living in 500 square feet, living in 700 square feet, and they show you the little apartment has like everything in it. It's like the size of that breakfast room. And it's a whole place. So the square footage, anybody want to guess? Yeah,
How much is the breakfast room?
the breakfast room is probably, what is it? 10, it's probably about, I'd say 150, 200.
Then I'm gonna say 100.
Okay,
And also, has anybody
right,
tried to
Yusuf?
live in IKEA?
800.
800 and
250.
250. All right, so here's our answer. 484 square feet.
That's a very random number.
Yeah, that's kind of like living in, well, maybe this space. That's the whole house. Okay. And the median is 179. So that means most people live in much smaller spaces. And then you've got a couple real big ones thrown in there to get your median all the way down this low. All right. So what we're going to do here is we're going to increase space for everybody. This is an imagination process. Okay. We're going to envision, we're going to give everybody in the world 1,000 square feet. That's a lot. So take everybody in your house and give them a big, huge chunk. Okay. So if we give everybody 1,000 square feet, the current world population is 7.9 billion, roughly, we're rounding up. So if we multiply that to fit everyone in 1,000 square feet, we're going to get a square mile. Let's just do this for a minute here. Okay, so this is a mile. Okay, 5,280, just kind of give you an idea. All right, so to house everybody at 1,000 square feet per person, about how many miles are we going to need? Yeah. It's a big one. He's working.
995.
Piper, what do you think?
It's on the
It's on the screen. Yeah, 1.5 million. There you go. I love it. I knew you'd seen it because you're looking at it. All right, so 1.5 million square miles. So could we fit everyone in the country, everyone in the world, sorry, everyone in the entire world inside the United States? Could we do it?
Large enough.
Yeah, you think we could?
Just got
Yeah?
passed off the
How many
top.
people think we could fit the whole world in the United States, giving everybody 1,000 square feet, which makes everybody's living situation better?
skyscrapers.
Housing,
Okay, so yes, we could.
infrastructure.
Mhm.
Yeah.
We're not talking that, we're just talking space. So 3.8 million is our square miles for the US. So yes, we could. So hold on. James?
A one-level house.
Yep, we haven't even gotten there yet. That's if everybody lives in a one level on the land, 1,000 square foot per person. Okay, so hold on. So, what?
Wait, what? Does it include the public ones?
Yeah, we're just talking, yep, the space, just to give you an idea. Okay, could we fit everybody inside the contiguous US? That means no Alaska, no Hawaii, no Puerto Rico. We think so? Who votes yes? Yes? All right. Yep. And how many square miles is that? 3.1.
That big. It
So
is
it's a
not
big chunk.
2.5 million.
All right, so here's this one. Actually, at 1,000 square foot living space per person, we could, let's just say fit, sorry, we could fit the entire world's population in Alaska, Texas,
Montana's up there twice.
California, oh, it is, Montana, New Mexico, Arizona, and Montana again. Yeah, I said Montana twice. And as James pointed out, if we construct only 1-story buildings. So living space wise, we have plenty of living space. The people that are worried about space don't need to worry about space because we could spread the whole world out in a couple US states, everybody in a 1-level house, 1,000 square feet, every human. That's a lot. All right, so, yes, question? I mean, yeah, because we would have had more than enough room. So we wouldn't have had to lay them like cubes. So what's our impact on the land? So we're going to roll through these so that we can get to our movie soon. Okay, so each year in the United States alone, a typical person consumes resources equal to the renewable yield from approximately how many acres of forest or farmland? Alex?
I'm gonna say 3,700.
3,700. What do you say, Yusuf? Okay, he's being very specific. Yeah, you're down at 12.35 or 12.5 is close enough. That was very specific. All right. So you need a lot of acreage now to feed yourself. So we were just talking about living space. Now we got to feed ourselves. So what happens when we mine? Okay, extracting of mineral resources. Most of this is done through mining. So modern societies such as ours require large amounts of land resources. Unfortunately, the extraction from the land is going to disturb large areas of the Earth's surface through surface mining and underground mining. Surface mining, we have a lot of around here. We have at least 2 granite mines. We've talked about them before. There's that one off 141 right there in Johns Creek, and there's the other off Ronald Reagan, and those are very close by. And there are others kind of spread out throughout Atlanta. If you've seen any of like the Walking Dead quarry or the quarry where they pulled Will out of the water in Stranger Things, that's down I-20.
Wait, where's the whale?
It's that particular quarry is in it's down I-20 towards Dallas, Georgia, that direction. Yeah, that same quarry has been used in a couple of filming opportunities. Yeah, so we have lots of surface mining. Underground mining, yeah, underground mining is when you go totally under and you don't rip up the whole surface like we do with granite. So as a result, Surface Mining Control and Reclamation Act of 1977, so there's a 46-year-old law here, requires mining companies to restore the land to its original states and replant vegetation in a process of what? What do we call it? Yes, Caitlin. Yeah, there you go. Reclamation, which repairs much of the damage left by Bailey. Yeah, the mining, the extraction. All right. So the problem is, though, this doesn't happen overnight. I mean, surface mines are there for years and years and years and years. So all of that, thanks, Mel, you can keep it, you got it. So all that causes more and more, erosion and issues during the time frame that land is all basically opened up. So agriculture, forestry, and urban development. So growing populations increase the demand for food. And when land is cleared for food production or agriculture, what do we lose through this process? Yes, Chloe. There you go. Yep, we're losing topsoil. Now this is back to we're back to the very beginning, right? We're back to first quarter when we were talking about erosion and whatnot, right? So you lose this topsoil, and then your pesticides and insecticides run off, right? And they interfere with life in other places. Remember what happens when fertilizer gets into water? Do you remember?
It causes the algae bloom.
Yeah.
It gets so gross.
Yeah. Now, speaking of algae, have you guys seen that we're about to get, there's this giant seaweed, Matt, the size of Florida, heading toward us? No joke, for real. Read about it. It's fascinating. Yeah, it's almost like a stromatolite on steroids. It's literally a mat of seaweed, they say, as big as Florida, flowing through the ocean, and it's going to slap into somewhere sooner or later. It's been on the news recently. It's weird. Very weird.
Florida, it just comes
Yeah.
like a blanket.
So we lose topsoil through, what's this one? All right, Yusuf. Yep, deforestation, which is removing, obviously, vegetation from the land. And deforestation is a situation where at least if you take the trees down, you can plant them relatively soon after having done that. Whereas strip mining or surface mining, it takes a while. You can't just take that resource out real quickly. So negative impacts of deforestation, obviously you're going to get erosion and runoff. And then you've also got the issue of lack of food and lack of habitat for organisms in the area. So development of land, of urban development affects the environment in several ways. Natural habitats are lost, topsoil is eroded, agriculture land is lost, and what is going to increase? Runoff, because there we've got our pavement again. All right, so we talked about that way back when, right? Way back when. And that's exactly what happens. So what are some of our solutions here? So as people become more aware of the need to protect the environment, most of the problems associated with land development are being solved. So what do we place around these construction sites to catch the sediment and increase from the increased erosion? Piper. Yeah, those little walls, those little fences, barriers. The orange cat, yeah, those are one of them, but y'all back there, you good? You seen the little black, it's a fabric, but it's a plastic fabric, and silt fences. Those are real important.
Put something on the road.
Yep.
They failed horribly because we had so much rain and the entire road
Yep.
was covered.
Mhm.
Thankfully, I wasn't affected.
It looks like somebody just
On the way to
took
dance,
dirt
we're
and
over.
just sprayed the.
When they tore out the forest behind my old house to build a subdivision, I watched when we had a really heavy rain and we had a creek back there, and it was at a swell that it had never been at before because that runoff was so increased. Okay, so what's protected in the US and recognized as valuable ecosystems? Do we know what we're looking for here? Do we know? James, you want to guess, don't you? You look like you want to guess. You're looking like you want to guess. Bailey, you want to do it? Forester one. Yeah, we're looking for wetlands here because that was in your book. But yes, all these things are protected. Forest too.
We'll keep the note.
There's one. So what are now built to minimize leakage of toxic waste? Do we know what this one is? So this one's interesting. This, oh, sorry, landfills are built to minimize. And I meant to click on this one. So bioremediation. This one might be on your test. Everyone's head whipped around. Bioremediation, use of organisms to clean up toxic wastes, right? And this is being used more when you got like contamination stuff. So plants that contain bacterial genes are grown in contaminated soils, and the plants convert toxic compounds into non-toxic substances and then release them back into the air. This is one way that we're using bioremediation. So what's our impact on the air? So obviously we know we can pollute the air. Everybody's been somewhere where you've got nasty, I mean, everybody, right? You've all experienced it. My worst was when we went to Shanghai and Beijing. When we landed in Beijing, we weren't even on the ground yet. And you're in the sky, you know, and you're in an airplane and it's like blue and there's white clouds below you. And we came in, and as we came down, all that white turned yellow. No joke. It was yellow fog. It was like a yellow fog. And you could, before we hit the ground, you could taste the air. It tasted metallic. That's how bad it is. It's really bad. So what is that stuff that we saw? This photochemical haze, what is it? We had to fly through. What is it, Milo? That's smog, nasty, right? So it's caused by the action of solar radiation. So you got sun rays, and this is when it hits certain hydrocarbons, there's some chemical reaction going on. So you got smog in a city and it can make it harmful to breathe. Major chemical in it is ozone. And we know that ozone is good up there, yay, but we don't necessarily want it down here. In the summer in particular in Atlanta, they do give, for the weather update, they do give a smog alert every day, and they tell you how high or low it is. And if it's a nice clear day and you're driving into the city, you can sometimes see it, especially when it's hot out. You can see this area around the city that looks kind of gross like that.
Well,
That's exactly what Beijing looked like, by the way. And when we arrived, the lady that was our tour guide said, hey, if you'd have come here 2 weeks earlier, it was the most beautiful it's been in years, because the G8 was here. So all these world leaders came, and they shut down the factories for 2 weeks before they all came so that it wouldn't be like that. She said everybody was out walking. People had taken their masks off, because this is before COVID, but people wore masks because you can't breathe, right? So imagine that, living where you have to wear a mask every time you go outside. No thanks. No thanks.
We've already done that with COVID.
Yeah. So what about the water? So we require fresh water, obviously. Some areas the supply is too low. So since 1960, fresh water has been increased by what percentage? What do we think? Jack. 64, 100. So, and is expected to continue to increase. Most people use fresh water in their homes, right? This is what we bathe, drink, cook with. What requires water, but much of it is wasted due to evaporation and seeping into the ground? What uses the most water? Piper. Yeah, farming, agriculture, crop irrigation. This is what uses the most of our fresh water. Pollution is another area where humans have an impact on water supplies. Water pollution sources are grouped into two main types. Do we know what they are? There are two main types of water. What is it? Water.
Point source and non-point
Right on. Point source and non-point source. So ocean pollution is possible in coastal areas due to sewage and stuff that gets dumped in, which is pretty nasty, or trash. And it can extend into what they call dead zones, where there's like just no living things because it's gross. But when we have our point source and non-point source, so this top one here is our point source. And this means your pollution is coming from a single place. So this is like you see one pipe from a factory dumping its waste into one pond. That's a point source. And you get bacteria and viruses that enter that water system, and then the whole thing becomes toxic and it's a giant mess. Non-point source is widespread. So you've got rainwater that's, coming down as acid rain, and then it's runoff, or you get runoff from roads and it kind of spreads out everywhere. That's your non-point source. So how do we decrease it? So we've had a couple laws. We had Safe Drinking Water Act, and then we had Clean Water Act. This is just our government coming in, making laws to try and keep our water safer. So then, who's heard of Flint, Michigan? Anybody know about Flint, Michigan? This was a couple years ago. Did he go there? Good thing. Hope he didn't drink the water. So Flint, Michigan Here we are, a developed US city that suddenly had absolutely toxic water. It became like a national concern, huge tragedy. What happened? How do you get that in a major US city?
I feel like crime was involved.
It's kind of always crime when there's politicians involved. So this one's a little long. I'm gonna check the copier again, okay?
Control of an emergency manager appointed by the state of Michigan to help the city through an ongoing financial crisis. Flint, Michigan switched its water supply. For decades, the city's water had been piped in from the Detroit Water and Sewerage Department, which got its water from Lake Huron and treated it. So in April of 2013, the decision was made to build a pipeline and connect to a new system, the Carignan Water Authority. This would supply the city with lake water that Flint would treat instead of Detroit, and was estimated to save $200 million over 25 years. In the meantime, as a sort of temporary fix, while the pipeline was being built, water would come in from the Flint River and be treated at Flint's water treatment plant. Now, 4 years after that switch, we know that it damaged hundreds of millions of dollars of infrastructure, caused deadly bacterial outbreaks that killed at least 12 people, and exposed thousands of children to high levels of lead in their drinking water. There are places to learn about the story of how this happened, was covered up, and was eventually recognized, and the underlying situations that caused these massive mistakes to be made. So let's talk about the science of water and how something as seemingly simple as switching to a different source of water could lead to so many bad, but also seemingly unrelated outcomes. Humans have actually been using lead pipes in water systems for hundreds of years, dating back to the ancient Romans. We eventually moved on to using other materials like iron, but in the late 1800s, engineers in the US were all about lead because lead pipes were easier to bend around obstacles and were a bit more durable than iron. People were suffering from lead poisoning, but the public health risks weren't seriously acknowledged until around the 1920s. And we gradually stopped making new water pipes from lead. But in lots of cities in the US, like Flint, Michigan, there are still several different kinds of metals in pipes for water. In Flint's case, the pipes are made of lead and iron. The US Environmental Protection Agency didn't have any sort of serious regulation about lead pipes until the lead and copper rule was enacted in 1951. It requires regular monitoring and action plans if old lead pipes start becoming dangerous. So all that to say, lead water pipes are not that unusual. A 2016 study estimates that there are still millions in use. And even though no amount of lead ingested by a human is considered safe, maybe surprisingly, many of these water systems are usually safe. A big part of the reason why is anti-corrosion chemicals in the water, like orthophosphate. Orthophosphate helps lead and some other metal pipes from corroding by forming a compound that makes a sort of protective layer on the inside of the pipe. If that layer is patchy or missing, then electron-stealing chemicals called oxidants, like dissolved oxygen gas, can react with the lead. And when that happens, the lead will dissolve into the water and contaminate it. You've probably heard of that. It's known as leaching. And it's when things get dangerous for people who need this water to drink or shower or do anything with on their bodies. Flint, and it is unclear why, besides possibly cutting costs, did not add orthophosphate or any sort of anti-corrosion chemicals when this went to Flint River water, even though the treated water from Detroit had them. And because Flint was using iron and lead pipes, both iron and lead ended up in the water. But that's not the whole story. Not only were these pipes left unprotected, but the water flowing through them also contained higher than average chloride levels. Researchers found that chloride helps the process of corrosion along. When there are enough chloride ions in the water compared to some other ions, they start forming chemical complexes with lead and other atoms. And these chloride complexes are soluble. So basically, it's another way that lead can get into the water. Part of this too much chloride problem was from the river water itself. Sodium chloride, which is just table salt, would often wash into the river after being used as a de-icer on roads. But another part of it had to do with the fact that a couple of months after the switch to the Flint River water, there was also a huge bacterial problem. The river water wasn't just like extremely dangerous though. We know how to treat water. We put in disinfectants like chlorine, which can rip open bacteria or mess with the molecules inside them. But turns out that chlorine disinfectant can react with metals from corroding pipes, especially iron, to become completely different compounds that do absolutely nothing to control bacteria. So the disinfectants were made useless. Plus, more chloride ions ended up floating around, which only made the corrosion process worse. And thus, the vicious cycle escalated. By August of 2014, there was a city warning that E. coli and other typically gut-dwelling bacteria, collectively called fecal coliform bacteria, were thriving in the water and could make people sick. The Flint treatment plant upped the amount of chlorine they were using to try to kill off these contaminants, but because the pipes were already corroding, it wasn't working. Not only that, all this extra chlorine they were adding also reacted with some of the organic chemicals from the river water to form disinfection byproducts called trihalomethanes. And researchers have found trihalomethanes to be linked to health problems and even cancer. So not only was the chlorine turning into a bunch of non-disinfectant chemicals, one of those was potentially a carcinogen. Trihalomethanes in the water quickly swelled to above the national regulatory limit. So to try and fix that problem, the treatment plant added coagulants that would react with the organic matter in the water to help them filter it out. Specifically, they used a chemical called ferric chloride, which took care of the trihalomethanes, but meant they were adding even more chloride to the water. As the pipes got worse and more chlorine was turned into useless compounds, the elevated bacterial levels became deadly. Between April 2014 and October 2015, at least 12 people died and 91 people got sick from an outbreak of Legionnaire's disease, the third largest recorded in
U.S. history. Before the switch to the Flint River water, there were only a handful of cases per year. Legionnaire's disease is basically a really intense pneumonia. It's caused by breathing in waterborne
Dude, hold up.
bacteria that infect the
Dude, what in the world? Okay, sorry, that was weird. No, somebody's rebooting a router in this house or what? That was fun. Do that again. Fortunately, it should be a quick fix.
What are you doing?
Fibers, stop committing.
Wall closet.
It's assault. I feel assaulted. Oh,
Oh, there we go.
Okay.
All right. Don't pillow fight.
Simply as hot chocolates.
I feel assaulted.
There's no people.
Okay, let's figure out where you were. You were probably about
12 people
and the
died.
chloride ions in the water.
Did you see this yet?
Started forming chemical complexes. Just in 2014, there was the city warning that E. coli and other typically gut-dwelling bacteria developed the regulatory limit. So to try and fix
Here we go.
that
This is
problem,
where you
the
were.
treatment plant added coagulants that would react
Hey.
with the organic matter in the water to help them filter it out. Specifically, they used a chemical called ferric chloride, which took care of the trihalomethanes, but meant they were adding even more chloride to the water. As the pipes got worse and more chlorine was turned into useless compounds, the elevated bacterial levels became deadly. Between April 2014 and October 2015, at least 12 people died and 91 people got sick from an outbreak of Legionnaire's disease, the third largest recorded in U.S. history. Before the switch to the Flint River water, there were only a handful of cases per year. Legionnaire's disease is basically a really intense pneumonia. It's caused by breathing in waterborne bacteria that infect the lungs, so they get inflamed and lead to other symptoms. This outbreak was caused by a bacterium called Legionella pneumophila, specifically the serogroup 6 strain, which isn't usually detected in the standard urine test for the disease. After some extensive studies, most researchers agree that this chlorine inactivation at least played a part in letting these bacteria flourish. On top of that, some of the experts and investigative journalists think that there could have been more deaths than were officially confirmed because of how tricky it can be to diagnose Legionnaire's disease. Some deaths caused by these bacteria could have been attributed to pneumonia in general and thus not counted. So counterintuitive as it might seem, not adding corrosion control also deactivated the chlorine disinfectant to basically undetectable levels, resulting in tragic loss of life. In addition to all this, though, there was the ongoing problem of metals leaching into the water supply, which we definitely know was because of how the Flint River water was treated. Because of all of these chemical reactions, the process by which lead and other metals got into the water was not slow and constant. Sometimes the pipes would leach metal slowly, but sometimes metal compounds like the protective layer that wasn't being maintained flaked off in little hunks, some of which were even visible to the naked eye. The leached iron made the water look kind of horrible and taste kind of rusty, but it isn't a big health concern on its own. Lead is, but you can't see, smell, or taste it in water. A single tiny lead flake can take water from safe to far over the EPA's limit of 15 parts per billion, which requires public action to be taken. And besides randomly super contaminated samples being right next to uncontaminated samples because of flakes, the protocols for testing for lead can be manipulated to make it less likely to record how contaminated the water actually is. Official EPA protocols for measuring drinking water quality involves letting the water sit in pipes for at least 6 hours and then collecting it after a couple minutes. City protocols called for pre-flushing the pipes for 5 minutes before letting them sit for 6 hours. And according to experts, this pre-flushing can sweep out initial bursts of lead particles so they're not in the sample. Plus, people don't just go turning on their water every once in a while, so those samples aren't necessarily reflective of what they're using and drinking. Even still, when the city of Flint tested one resident's water in February and March of 2015, they found lead levels at 104 parts per billion and 397 parts per billion, far above the EPA's action level. When researchers from Virginia Tech sampled water from the same pipes at low, medium, and high flow rates, they found levels ranging from 220 parts per billion to a whopping 13,200 parts per billion. And to be totally clear about how intense this is, a substance with more than 5,000 parts per billion of lead is considered hazardous waste by the EPA. By September 2015, those same researchers had collected and analyzed 252 water samples from various Flint homes. 101 of the samples had more than 5 parts per billion of lead, and they estimated that 90% of homes had a lead level below 25 parts per billion. 10% were above that, which, and I can't say this enough, was a lot of homes above that 15 parts per billion EPA limit for water. Protocols matter, y'all. So that's how metals end up in the water. No corrosion control and high corrosive chemical concentrations exposed many thousands of people to lead poisoning. And lead poisoning can cause incredibly serious health problems. Lead interferes with a lot of different enzymes, can cause cells to die, and can slip past the protective brain barrier. It's seriously.
Ah, dude. I love it when they do that.
Well, they're getting killed by the lead, they're also getting infected with flames.
I'll put this in your, I'm gonna put this in your study guide, so you can, you can watch the rest of it later. But I want to move on because we've got, well, nothing's moving. That's fun. There we go. Oh, that's fun. Look at this. No, that's actually my computer being done, but I don't know why. So we're about here to the end. Here we go. Whoa, look, it did everything real fast.